Assalamualaikum and a very good morning to respected panels, my fellow presenter from Malaysia and Indonesia, and lovely audience. Today I'm Nur Shahira binti Muhammad Nasir would like to present my thesis review with title Antimicrobial Effect of Extracted Chitosan from Fungi on Gram-negative and Gram-positive Bacteria. As for the introduction, chitosan is known to be versatile hydrophilic polysaccharide, which has a broad use. Kumar and Abu El-Saud in their study in 2020 and 2019 respectively states that chitosan is a versatile hydrophilic with strong antimicrobial effect. The main source for chitosan usually come from marine-like crustacean. Based on the study by Huang and Verley, chitosan can be found in crustacean, fungi, and even insect. Unfortunately, the process uses for extracting chitosan from crustacean exoskeleton is more complicated. According to Sebastian in 2020, fungal source chitosan has a straightforward extraction step. Besides, bacteria types, deacetylation degree, and molecular value of chitosan has effect on antimicrobial activity. And you can see over here, this is the structure of the chitosan. Now, we move to problem statement. The main source of chitosan is crustacean, but it is limited due to seasonal. Moreover, study by Batista in 2018 state that the extraction process is costly due to more complicated step. In addition, marine-based chitosan product might trigger allergic reaction to some people. The objectives of the study are to discuss the antimicrobial activity of fungal chitosan towards different strain of bacteria and to discuss the potential uses of fungal chitosan so that it might suitable to be more affordable alternative than crustacean source chitosan. Why this review is significant? First, it gives some insight on the potential use of fungal chitosan. Second, as a foundation to understand the effect of deacetylation degree and molecular value of chitosan towards antimicrobial activity. Next, literature review. The first subtopic is chitosan as an antimicrobial agent. A lot of study has been made on marine source chitosan, but not fungal chitosan. Also, many studies reported on the possibility of developing chitosan as a natural antimicrobial. Study by Duan in 2019 found chitosan to be effective against gram-positive and gram-negative bacteria, while according to Goy in 2019 state that chitosan can be an agent of antimicrobial against wide range of microbes. Next is degree of deacetylation, molecular weight, and concentration. Besides that, deacetylation is the reaction of removing the acetyl group from molecule. A study by Tahil in 2010 claims that the higher the deacetylation degree and the lower the molecular value result in better antimicrobial activity of chitosan. In this study, chitosan extracted from mucorrhizae with highest deacetylation degree of 95% and lowest molecular weight of 2.1 plus 10 to the power of 4 Dalton inhibit bacteria better. While, according to Zaglow in 2015 states that increase in concentration result in better antimicrobial activity of chitosan. The study records the increase of fungal chitosan concentration leads to the increasing of antibacterial activity for Escherichia coli, Salmonella typhimurium, Bacillus cereus, and Staphylococcus aureus. Move to sensitivity of microorganism strain to chitosan. Chitosan showed Chang 2019 states that chitosan showed greater effect for gram-positive bacteria than gram-negative bacteria. According to Rafat in 2008, the difference of sensitivity between these two strains is due to the teichoic acid on the surface of the gram-positive bacteria. Teichoic acid are polyanionic polymers that responsible making the whole surface negatively charged. The cationic chitosan binding with teichoic acid disrupt the teichoic acid, thus altering the peptidoglycan, make it more susceptible towards chitosan. While gram-negative bacteria resistance is due to the triple layer, which is the outer membrane, which is the unique feature that distinguishes it with gram-positive bacteria. And the second layer is the rigid peptidoglycan, and the third layer is the phospholipid bilayer. That triple layer leads to its resistance towards antimicrobial agent. As you can see over here, this is the picture of the gram-positive bacteria and the gram-negative bacteria, and this is the teichoic acid that actually be the reason or another reason that makes the gram-positive bacteria more susceptible to wide range of antimicrobial agent. And this is the gram-negative bacteria. As you can see, we have the outer membrane, the peptidoglycan, and the third layer, the phospholipid bilayer, or we can call it as a cell membrane. The last subtopic is fungal chitosan, marine chitosan, and commercial chitosan. A recent study conducted by AKT Chang extracted chitosan from species of fungi known to be Auricularia species inhibit bacteria at lower concentration than commercial chitosan. This result showed that extracted chitosan is more significant in antimicrobial activity. According to Darwish in 2018, added that chitosan inhibition zone is always greater than marine source chitosan, like shrimp. This is the result from Darwish study. As you can see over here, fungal chitosan has a bigger inhibition zone that tested for every bacteria, always a bigger inhibition zone than the shrimp chitosan. For the summary and conclusion, fungal chitosan make an added point as it is a greener source of chitosan that benefits many sectors. Antibacterial effect of fungal chitosan also recorded from many studies to be potentially enough to compete with other chitosan sources. My suggestion or recommendation, chitosan, specifically fungi source chitosan, can be found worldwide. Even the function is vast. The ability as antimicrobial agent also wonderful. Still, further study need to be done to ensure that fungal chitosan is potentially enough to compete with main sources. Thank you.